video we're going to have a look at some of the identification of magnesium and barium salts and also the use in order to test for sulfates and hydroxides of the group 2s. So we're first to try to confirm the presence of magnesium 2+ ions, and you maybe demonstrated this or watched on video. This is done by adding aqueous sodium hydroxide to the solution of the group 2 compound, and you can observe if there was any precipitate formed. So in this reaction they've taken a group 2 chloride plus sodium hydroxide, formed the hydroxide, the methyl hydroxide that we know it will make, plus the salt. If you started with something like magnesium chloride, you would end up making magnesium hydroxide. We already know that magnesium hydroxide is sparingly soluble, therefore it will come out of solution and you'd see a thick white precipitate. Written the ionic equation there, so your Mg2+ aqueous ions plus your 2OH- aqueous ions gives MgOH2, and obviously that's a solid, that's the white precipitate that you see. If, however, you'd added something like barium chloride to your sodium hydroxide, you'd form barium hydroxide. This is much more soluble, so the precipitate does not form, and you just see your colourless solution. Barium hydroxide, much more soluble when it's made rather than the magnesium, so you wouldn't see any precipitate. How could we test then for the barium ions instead? This would be done by adding a small amount of sulfuric acid or aqueous sulfate to your solution, and you can observe again if a precipitate is formed. Because we're now looking at the sulfates, remember magnesium sulfate is soluble, so you would not see any precipitate. Whereas with the barium sulfate, when you made that, that's insoluble, so you would indeed see a nice thick white precipitate, so you could tell which one was your barium. Writing an ionic equation for that then, you've got Ba2+ aqueous, that's your ions, plus your sulfate ions, which will come from your sulfuric acid, giving you BaSO4, that's your insoluble white precipitate. So as it importantly says there, the solubilities of the group 2 hydroxide and sulfate can be used to identify which group 2 ions you have. So rather than actually testing for the magnesium or the barium, now we're going to use the group 2 metals to actually test for other substances. So we're going to use barium salts, and we're going to use them to test for sulfate ions. So you may have seen this test either demonstrated or on the video. You can probably pop the method in. So you'd have a small amount of solution, your unknown solution, in a test tube. You'd firstly add 1 cm³ or a small amount of HCl. This is there to remove ions that could interfere with the test and give you a false positive. So it removes things like carbonates. You would then add 1 cm³ of barium chloride solution to your test tube. If a sulfate ion was present, then barium chloride would react with sulfate ions and produce barium sulfate, which is a thick white precipitate which you would see. And that's the ionic equation again, which we saw in the last video. So making your BaSO4, which is your white precipitate. Barium sulfate is very useful within medicine. It can be used as what we call a barium meal. The barium sulfate can absorb X-rays, makes it much easier to take X-rays of your intestines. So it is used within medication. The barium ions themselves are very toxic, however, but it's a harmless technique when it's used with the barium sulfate, because the barium sulfate itself is insoluble, so it doesn't get absorbed by the body in any way. So having looked at the use of the barium salts, in particular barium sulfates, barium chlorides, we're now going to have a look at the uses of magnesium salts. Magnesium salts can be used for the test for hydroxide ions. So firstly put 1 cm³ of your unknown solution into a test tube. Add 1 cm³ of your magnesium chloride. Again, you might see this demonstrated to you. If hydroxide ions were present, the magnesium hydroxide that they're made would be insoluble, therefore you'd see a white precipitate of that material. And there I've written the ionic equation, which you've seen before. You're taking your Mg2+ aqueous ions plus your hydroxide ions and making MgOH2, your magnesium hydroxide, which is insoluble, therefore white precipitate C. And lastly, within this pack, we're going to have a look at calcium in group 2. We mentioned this reaction back when out in alkanes, when we looked at crude oil, and we saw then that calcium oxide or calcium carbonate can be used to remove sulfur dioxide from flue gas. Both calcium oxide and calcium carbonate are basic, therefore they will neutralise the sulfur dioxide, which is an acidic gas, and you could have a go at writing equations for the reaction of those with SO2. I'm going to pause the video.